read through this on your own. So after 22 games in 2005, J.D. Drew of the LA Dodgers had 10 runs batted in. Now this means we're going to deal with like a rate of change, which lends itself to slope. Well, after 36 games, he had 15 runs batted in. And then we have to ask ourselves, are we looking for runs batted in, which is RBIs, per games, or games per RBI? Well, RBI per games makes more sense, so we will keep it the way I wrote it in red. So here the rate of change, well, he had 15 runs batted in after 36, but only 10 before. So in between those 2 points in time, he went from 10 to 15, so 15 minus 10 will give us that difference of 5. But that didn't, happen since the beginning of the season. It happened between 36 and 22 games. So here I'm going to take 36 and subtract 22, which would give me 5 RBIs for every 14 games. And that means that, basically I can expect him to every game make 5/14ths of an RBI. And the only thing that's missing here is what the slope would be. And since we're approximating here, it's not like this is going to work out. What the y-intercept would be. So we know that here's what we're targeting. Y equals mx plus b. Well, we do know the slope, but we wish we had the y-intercept. And this means that we can either treat 22 games and 10 runs as the other point, or 36 games and 15 runs as the other point. So no reason I'm going to choose 36 games and 15 runs. So I know this equal sign is going to stay the same. I know 5/14ths. And so now x is going to be the games. We don't know b, but we would know that after those 36 games, he did get 15 runs batted in. So now we just have a equation to solve. When I go through this, I'm going to simplify 36 over 14 to be, I guess that doesn't really save us that much time, 18 over 7. And now it looks like we're going to have to pull our calculators out. So here's 15 equals 90 sevenths plus b. Then I'm going to take 90 sevenths away from each side. Which means that b is going to be... Now, over to the side, you'll notice that I actually did figure out what this would be as a fraction. And that's important because when you're dealing with slope-intercept, you want to not round whenever possible. So here I am converting it to 105 over 7, and then subtracting 97ths from each side, which leaves me with 15 over 7 here. And then last, final step, don't forget to rewrite y equals mx plus b with the correct values in place. And then if you plugged in both of these values and used a calculator, so like you would have coordinates of 22 games, comma 10, and then 36 games, comma 15, you should have equal sides on the left and right. Alright, got another problem coming your way. Alright, so read this to yourself, and I'll talk about it too. Now in the last one, we did really find a couple of different points. So this time let's make it even more specific. So we'll set ourselves up with a couple of coordinates that we could get from this. So if Ethan makes deliveries, we know that he's paid 16 per delivery. Last week he made 5 deliveries. Well, that seems like a reasonable input. And his total salary was $215. And I guess I realized, well, maybe we don't have a second coordinate. So we only have one single point. And they're telling us that they want us to do salary if he makes D deliveries. So here I'm going to have capital D because he made 5 deliveries, and then his total salary was $215. But usually these D's and s's and different variables can trip us up a little bit. So maybe we'll keep with our normal x's and y's. So I'll set up y equals mx plus b. We know that that's usually the target. And we know an x, and we know a y. So we have two of those things, and we can definitely plug in a coordinate. And if we know either the slope or the y-intercept, we're good. So that means we either know the slope or the y-intercept. And I don't think we know this one, but we do know that it's $16 per delivery. So on the left side, I'm going to plug in 215 for y. Where I see an m, I'm going to write 16 times 5 for x plus b. And then now I'm solving one. And I think this is a little bit more straightforward than the last one because we're not dealing with as large of values. So that when I simplify, or really just subtract over here, I think it's 135. Having solved for the y-intercept, we now can just plug in for the generic equation, 16x plus 135. And I can check the other one, and we'd be good to go. Now this is a little bit strange because it jumps back to the earlier problem. So he played 72 games during the 2005 season, which means we'll be reusing 5/14 x plus 15/7. So here's 5/14 x plus 15/7. Which means, do we know this? Yes, so we'd be solving for y. That'll be an OYO problem. So hopefully this helps you with some of those word problems. See how they go.